When you ask a question, please give us your name and also obviously the media you're representing. So, do we have anybody who wants to ask a question? Maybe first question, shall we start with Spike Global?
Yes.
Thank you. Steve Dribble with Flight Global. This is more of a technical question with on the military side. With the adaptive technology that you were talking about, you mentioned what you can do with the controls in the engine, as well as the third stream architecture, and then the improvement in OPR, or the adaptable OPR. And so one thing I'm really interested or fascinated in, how you do adaptable OPR. And then also, if you could break down what the performance improvements, they say adaptive is 25% more efficient than conventional. How much of that can you get from the control improvements, what you can do with the FADEC versus what you do with the third stream architecture? Sorry, very long question.
Right. So, yeah, the question is, looking at the adaptive architecture, what are the innovations and why do they work? So, again, as I said in the presentation, Pratt Whitney really pioneered adaptive architecture with the J58, and we're fielding today with the JSF and even the 119. And when you talk about adaptive, it really is, in simple terms, a change from where we used to be in terms of point designing engines to operate at the most efficient point you could, but at the critical operating point in the envelope, to being allowed to change how it performs depending on where you are in the operating envelope. So we get to design a motor that can be high thrust, for instance, when the fighter needs it to get in and out or to maneuver quickly. But at the opposite, it can change its configuration to be low fuel burn and allow it to stay on station longer or allow it to have a longer range. So in simple terms, we are creating an engine which can change its configuration so that it can operate in multiple points in the operating envelope very efficiently. So adaptive can refer to the operating pressure ratio of the core. It can refer to the third stream architecture, which gets a lot of visibility. It has to do with the controls that we have in order to optimize engine performance at these different elements. We even have adaptive thermal management systems under development, which can optimize the ability of the engine to cool not only engine components, but offer more cooling capability to the weapon system, which is important for high-tech weapon systems on the air system or just cooling other parts of the aircraft. So the concept is to have your cake and eat it too, to have the high thrust when you need it, to have the low fuel burn time on station. How we do that, all of that is classified in the way that different systems work, but it's a combination of material technologies, software IT technologies, and the system engineering knowledge that we have allows us to combine those three things today and do that in a very cost-efficient manner that can modify the physical aspects of the motor and the control aspects of the motor so they can perform at different points in the operating envelope. We think it's really the next generation, I said, in fighter engine technology. It's the next generation in Pratt Whitney military engines, and we're going to spiral those technologies into each motor as they're ready.
Thank you, Matthew.
Thank you.
Shall we continue? I don't know, maybe it's for the local Florida, the Sun Sentinel.
Hi there, Marcia Pounds. I'm with the Sun Sentinel. We cover both Palm Beach and Broward counties. I wanted to, obviously we're most interested in Palm Beach County and what you're doing here. So I'm wondering if you can, Bob and perhaps Matthew, address what's going on there now. I know you've had quite a bit of growth and what you see in the future.
Sure, I'll start from a military engine perspective. There's really, two center of excellence teams down here. The small engine business, which it has a 60-year history, but it's actually relatively new to West Palm Beach and the facility down here. So we're very excited. This is our center of excellence. It's where we're doing our engineering, it's where we do our assembly. We have a maintenance, repair, and overhaul facility. We have several hundred people that are working on that. Installed base of 11,000 APUs, plus we have about 8,000 of these TJ150s out there in the two configurations I talked about. And that's going to grow at 5 to 7% a year over the next decade. So that center of excellence is here, and the team size is going to be stable, but the opportunity and the impact it's going to have on the industry is significant. The second is for the Joint Strike Fighter program. We have an assembly center down here, which is one of two, but it's definitely a center of excellence for reducing the Joint Strike Fighter. And we do a lot of our engine testing down here, given some of the unique facilities. So we're going to be here for the duration. We're very excited about these two businesses, and it's an important part of our development and support infrastructure.
Could I ask one more? Do you see any additional production lines in Palm Beach County? And you mentioned, of course, getting into helicopters. I know Sikorsky's been acquired, and now you're getting into helicopters. Will that happen in Palm Beach County?
So it's too early to tell where the production and sustainment. We'll look at all opportunities when we get closer to that point in time, but we'll clearly want to leverage existing capability, but it's too early to make that decision.
Yeah. Anything to add, Bob? Good?
I mean, I think the facility infrastructure we've got we sized it for the growth. So what we can do down there is we can add more carriers to the assembly line, so we can do higher rate GTF production. On the F-135, we do all the international F-135s here in Florida. We do all the US government F-135 builds up in Connecticut. And, we did that because when we looked, the international volume is gonna get every bit as big as the US volume at some point in time, so we wanted to balance it. In terms of, the facilities size, we've spent since 2013 in Florida, we spent about $130 million between 13 and this year, through the end of this year. About $130 million on infrastructure and capital. And so we're gonna continue that. Actually, we've got a bit more to spend on here because we're gonna add more carriers and the like. But to Matt's point on the helicopter engine, it's too early to make that call. I mean, we're in a partnership with Honeywell, number one, and there'll be a joint discussion about that. Right now, I'm focused on winning it, and if I win it, then that'll be the next question. Obviously, we've got a workforce here. It could be a logical place, but it's like anything else. Competition's a wonderful thing, and we're gonna look at it carefully and decide what we do. But our first order of business is winning.
Very good. Next question?
Ernie, did you?
Should we get, inside the Air Force?
Hi, Courtney Alvin with Inside the Air Force. On the XA-101, can you give us an update on where you're at in that development effort? And then also, are you still planning through the AETP program to do a demonstration in 2020, or do you think you can speed that up?
So Courtney, let me clarify, the AET program, Adaptive Engine Transition Program, that is our XA-101, they're one and the same. We're on time with the contract, and we're hitting all the key milestones that the customer has in front of us. We're in front of them with quarterly reviews, and so we're very good about where we are. So that program is on time, it's on budget, we're hitting the the development milestones that we're supposed to hit, and we're excited about the partnership we have with them.
On the timeline for the demonstration, are you looking to speed that up at all?
We're going to respond to what the customer asks us to do, so if you have any questions about their discussions on where they want to do the program, I recommend you go to the Air Force and talk to them. We can speed it up if that's what they ask us to do, but we feel very good about where we are today, meeting all their development milestones.
How soon do you think you could do that demonstration?
That's something that we talk to the Air Force about. Thanks.
Shall we get on this side maybe of the room? Did you have Aviation Week or, okay, Reuters?
Hi, Zach Fagenson with Reuters. I guess I'm happy some other people asked about some other topics other than the GTF. But for this year, I believe the stated goal for the GTF was 350 to 400 engines, and I believe about 70 have been developed or delivered in the first quarter. What has to happen throughout the rest of the year to hit that goal? What kind of issues are there that might prevent it, and when do you see the bulk of those deliveries coming in?
I don't think there's any issues. We've been on record for quite some time saying 350 to 400 engines this year. We're on track to deliver 350 to 400 engines this year. We're in the middle of a ramp. We did 70 in the first quarter, so we basically did 23 a month. So you can figure out if you're gonna hit 350 for the balance of the year, you're gonna do 280 in the next 3 quarters. You know what we have to be at a monthly run rate, and we're positioned to do just that.
Okay. Next question. Do you want to go to Defense Daily?
Hi, Mark Sellinger, Defense Daily. I know you're probably limited in how much you can talk about the B-21, but are you able to provide any details about your work to date on that and any milestones going forward? And has a name been disclosed of the engine?
So, yeah, the answer is no, I can't provide any details on the B-21 program. We're thrilled to be on the program, and we're laser focused on development.
Not even a name.
No,
Not even a name.
we can't even spell B-21.
Yeah. Can we continue with Aviation Week?
Yeah, sorry. Just in terms of the one more adaptive question. You were due to run the 3-stream adaptive fan and also the new core as well by the end of, I think it was around now, basically. Yep. Can you say whether that's taking place now? Has that actually occurred?
Yeah, I can tell you that the development program is on time, and we'll be announcing the results of our tests in the near future. We're not done with them, but we feel very good about where we are.
Okay, very good. Over on here.
Hi, Valerie Zinno with Defense News. I had a couple quick questions about the F-135 growth option.
Yes.
You mentioned that you guys could cut that into the production line around 2020. So what would be happening between now and then? And you also mentioned that the cost of the production engines would be about the same for that and then the growth option. But what would the retrofit cost be?
So obviously there's two ways to retrofit. So first, yes, you summed it up correctly. And it's not a program of record today, Valerie, so it'd have to be something that is launched and funded, but we've done the analysis that we could do it. If we started today, we'd be ready by 2020. In terms of cutting into production, we could manage that with the program office. And in terms of retrofit, it depends on how they want to cut it into production. You could do it on an attrition basis, so that as the core needs upgrading, you'd swap it out with the new growth option core, or you could drive the retrofit. If you do it on an attrition basis, the cost is going to be nominal because you're going to be changing out most of the hardware when you need it. If you force a retrofit, obviously you're going to have the cost of the core module, which I don't have in front of me at this point in time, but that would be the incremental cost. It depends on the needs of the operator and what the program office decides.
Okay, and sorry, just to follow up. So with my question about what's happening between now and 2020, if you guys got the okay, is more testing needed, or is that just simply to set up the production line?
So we'd have to launch a full program. The technologies that we're developing on the rig you saw yesterday, the fuel burn reduction rig, those are some of the critical technologies that prove that we can actually execute the program. We have technologies in all of our programs that are complementary. We leverage the fuel burn reduction program. We're going to leverage everything we're doing on the XA101. We pull that suite of technologies together. If we're given the green light to go, we would launch a relatively short engineering and manufacturing development program. We have to go through all of that validation, but we view that as low risk. As I said, if we were given the green light, we could launch the program and have it into production at 2020 and then start a retrofit strategy as needed.
Very good. Thank you. Do you want to continue here with Aviation Week?
Hi, first of all, just to clarify, so when you said the cost of growth option 1 was cost neutral, did that meant procurement cost of the engine? That would be the same. What did that mean exactly?
That is a procurement cost of the motor.
Okay,
right?
so
the hardware changes. We'd still have to spend the money on the development program.
Okay, so it doesn't include retrofit costs.
No, exactly. But as you said, if you're doing it on an attrition basis, you're going to be replacing hardware anyway. The cost of the hardware is roughly the same, so that wouldn't be incremental. If you force a retrofit, you're going to pay for the incremental retrofit cost.
Okay, and have you been funding the fuel burn reduction program, or is that Navy?
That's a Navy-funded program. Yeah, we're very grateful to them to help prove out the technologies that allow us to do this.
Okay, and then my real question is, could you lay out kind of a roadmap for growth option 1, growth option 2, and then how does that feed into AETP in the future? What's the line between growth option 2 and AETP?
That's a really good question. So, as I stated, having pioneered and now fielding the adaptive technologies and then looking at really defining it going into the future, we view the adaptive technology suite as an umbrella that's going to cover all programs. That full new center line, that's the XA101. There's a lot of work to be done on that type of engine program, but as each upgrade becomes available, we'll look at taking the elements of that architecture suite and inserting it into the motors as available. So growth option 1 would be the first opportunity to insert some technologies into that. And likewise, some of the technologies of growth option 1 are complementary to a new center line, some of the material technologies and some of the aerodynamic technologies. So they're definitely related, but the way I would look at it is adaptive architecture is the umbrella for the future fighter engine propulsion, and growth option 1 would be the first incarnation of upgrading the JSF to go down that direction. Yeah, and growth option 2, which is something we're looking at, another 4 to 8 years down the future in terms of capability. And obviously from an XA-101 perspective, it really depends on what the Air Force wants to do with that program once it's done out of this development phase.
But would AETP be, it would be for a future fighter, would it be for that?
That's a question you'd have to ask the Air Force on what they want to do with it. You know, we could upgrade the JSF with an adaptive core, or we could use it in an entirely new weapon system. That's a question for the Air Force.
Because there's a lot of time between 2020 and like when that 35 or when that 22 retires, so.
We're all about providing options. So, you know, we think the low risk, fast, low cost option for the JSF is growth option 1, this first incarnation of an adaptive set of upgrades. But we also think sometime in the future, if needed, you could use an XA-101 type core and put it in the Joint Strike Fighter.
Okay, I think we continue with Scott.
This is Scott Hamilton with Lehigh News. This will be for John. PWC has an overwhelming market dominance for the regional turboprop and in the PT6 arena, but GE is trying to come into that market or make greater inroads, and as Bob says, GE is a ferocious competitor. As you look over your shoulder toward GE, could you expand a little bit more on exactly how you see the markets developing going forward? There's all this talk from time to time about a new turboprop. Do you see a new turboprop airplane coming forward? Or is this all about just further enhancing the turboprop, regional turboprop engine and PT6 engines?
Well, first of all, I think that, like Bob said, we take GE very seriously in everything they're going to do, and you know, we've got to maintain the fact that we've had this lead. We earned this lead over time, but through technology. GE has come in. There's 2 aspects of the GE. There's the Walters engine, the so-called H80, H85, which, you know, we believe is a certain approach. And there, I think our PT6 and the approach of the PT6 are very competitive, and we go forward. The big change is that Cessna picked GE for the Denali, which is a single-engine turboprop that will likely replace the bottom end of the King Air lines, the dual props, just the dual engine airplanes at that end. So we see that as a very serious threat. Now, I keep talking about their 16-to-1 pressure ratios, and that's the be-all and end-all. We have 14-to-1 in some of our PT6s. But the 7 is up there. That's something that we will take the FADEX or the electronic controls we have in the PT6, then how to combine that with propeller control, get the single lever control that the Denali keeps touting. And we will also look at how we bring a better SFC to that PT6 without going to a configuration that we consider is to be non-robust for the type of application the PT6 sees on paved runways, dirt runways, that type of thing. We have a technology program in place right now to demonstrate those concepts. That'll give us a significant fuel burn. We've got a demonstration program right now running today for that single lever FADEC I talked to you about. So we will come and respond to that in due time. Do we see any new applications there? The turboprop is still a very effective way to transport, very cost-effective way to transport, especially the single engine. If you look at the PC-12 market, the TBM markets, they're both 60 to 90 aircraft a year and have been for many years. We think that the King Air platform is a 50-year-old platform, that somebody will come and look at replacing that. We believe the growth will be on the close to 2,000 shaft horsepower size engine, and that same engine will have a big application in the helicopter market. The helicopters are also pushing towards bigger engines. So in summary, we think there's a market for immersion. It's not just the Denali that's coming out. Second, we take GE very seriously. 3, we have a suite of technologies in development today that we think will maintain the robustness of the PT6 and give the fuel burn that everybody keeps talking about. And we have been in this business for a long time, and we have a great customer base, as Bob said. We're talking to our customers all the time, and we will be ready for the next application when it comes out.
And how about the new regional turboprop,
So the
ATR or Q400?
Yeah, the regional turboprop right now, that, you know, people have talked about a next generation airplane going to 90 passenger regional turboprop from the 70 we have today. The discussions have slowed down in the marketplace about that quite a bit in the last little while. So we are going to be ready when that comes, and we are developing that, what I call the next generation regional turboprop, where the compressor's been demonstrated, 50 to 20% SFC improvement over our PW127. That we'll be ready for, but I'd say right now we'll time that with the market, but we will certainly present something to the market when it's ready for it.
Thank you. I think we have one more question.
I'm Chris Kelgard, and I'm representing AIN. I wanted to address actually, particularly with Bob, you discussed earlier how you see additive manufacturing volume being still, 7 to 10 years away. What specifically needs to change, and how do you go about that? I think you mentioned, you need more laser capacity, or lasers need to be more.
The speed that the laser can lay the metal without changing the metallurgy. I mean, that's really the challenge. I mean, they can lay metal today and not change metallurgy. It's just not at a rate that you would say could sustain high volume production. And I think that's the issue. There are, like I said, for development tooling, development parts, probably makes a lot of sense. For high rate production, we don't believe the technology is quite there yet.
So do you need to develop that technology, or is it somebody else that's going to be doing that as to how, a faster laser or a more powerful laser, or?
I think it's a combination. I think there's different elements, right? There's people that actually make the lasers, there's people that actually decide how the metal gets laid, there's actually, the software. It's complicated, but I think at the end of the day, it'll probably be both the traditional suppliers of that equipment, plus some internally developed technology that we're working on.
Are you investing a significant amount into that?
We're spending money on additive, yes, sir.
Okay, thank you.
All right, I think with that, we are concluding our general Q&A session. So thanks everybody for being here today. This is the end of our official part. I think there's some lunch outside, and we'll continue with that. So thank you so much. Thank you.
Thank you.
Thank you.